What is the value of 2 to the negative third power? What is your prediction? In this lesson, you will learn how to simplify expressions with negative exponents by exploring patterns and making connections to your prior knowledge. So let's start with a review of exponents. Exponents, also called powers, tell you how many times to multiply a base number by itself. So here's an example. 2 to the 5th power is equal to 2 times 2 times 2 times 2 times 2. So notice there are 5 2's that are getting multiplied by itself because that's what the exponent 5 is telling the base 2. Let's also review something that we've been talking about this year, and that's inverse operations. So if I give you the equation 10 times 2 equals 20, we can kind of check that equation by taking 20 and dividing by 2 to get 10. But there's another way to do that division. So instead of dividing, we've been talking a lot this year about multiplying by the reciprocal. So the reciprocal of 2 is 1/2. We could also get 10 as a result by taking 20 and multiplying by 1/2. 20 times 1/2 is also equal to 10. That's going to come in handy today during this lesson. So let's look at the core lesson for today. Here I have this table of, what do we have, seven different expressions with different exponents, all with a base of 2. Let's focus first on the one kind of on the bottom there, that's 2 to the 1st power. That's something that we could do without a calculator. 2 to the 1st power means we need 1, 2. It's not getting multiplied by anything, it's just 2. If we go down to 2 squared, that's telling us that we're going to multiply 2 by itself twice, 2 times. So it's 2 times 2 is equal to 4. 2 to the 3rd power means 2 is getting multiplied by itself 3 times. So 2 times 2 times 2 equals 8. So we've just been going down the table, and to go down from 2 to 4 and from 4 to 8, we should already see a pattern. Something that we've been working on this year, looking at patterns with the recursive rule and the explicit rules. And so if we look at 4, 4 was a result of taking the previous term and doing what to it? If you say we're adding 2, then it has to be the same pattern from 4 to 8. Is that also adding 2? No, it's not. So what's another way that we got from 2 to 4, and that's the same way we got from 4 to 8? Well, we took the previous term 2 and multiplied it by 2. 4 is equal to 2 times 2. We could say the same thing about 8. 8 is equal to the previous term 4 times 2. So we took the previous term 4, multiplied it by 2, and that gave us 8. So that helps when we're going down, but we actually need to go up the table to get the other 4 blanks filled in. So instead of going from 2 to 4 and 4 to 8, let's go from 8 to 4 and 4 to 2. What happened when we reversed? Well, what did we do to 8 to get to 4? We did 8 times 1/2. You might want to say that we divided by 2, but remember we just talked about dividing by 2 is the same as multiplying by the reciprocal, which is 8 times 1/2. So we could do the same thing now with the 2. We multiplied the 4 times 1/2 to get 2. So if we continue that pattern of multiplying by 1/2, what would we do to get 2 to the 0 power? We would take 2 and multiply by 1/2, and 2 times 1/2 is equal to 1. So that's interesting. Any number raised to the 0 power is equal to 1. That is always the case. Any number raised to the 0 power equals 1. I would write that down if I were you. So let's continue this pattern now. If we take 1 and we multiply by 1/2, what is 2 to the negative 1st power? Well, 1 times 1/2 is equal to 1/2. Continue. Let's take that 1/2, multiply again by 1/2. 1/2 times 1/2 is equal to 1/4. So 2 to the negative 2nd power is 1/4. Multiply by 1/2 again, and we get 2 to the negative third power is equal to 1/8. So that very first question that I presented this lesson with, what is 2 to the negative third power? The answer is 1/8. I'm sure you guys had some different predictions, but if any of you had 1/8, kudos to you. So let's just take a look at the top 3 rows of that previous table. We're just looking at the negative exponents. So if we need to summarize this, I could start with 2 to this negative first power, and I know it's equal to 1/2, and I know that 2, the denominator, is equal to 2 to the first power. So I could say that 2 to the negative first power is equal to 1 divided by 2 to the first power. Well, I wonder if that holds true for 2 to the negative second power. It's 1 divided by 4. 4 is the result of 2 to the second power. So 2 to the negative second power is equal to 1 divided by 2 to the positive second power. Interesting. And does that hold true for 2 to the negative third power? Well, we know that 2 to the positive third power is equal to 8, so 2 to the negative third power is equal to 1 divided by 2 to the third power. Isn't that cool how that works? So to summarize, by using any letters, because this is algebra, so we can use variables, and if we're looking at a base b that's being raised to a negative a power, that is equal to 1 divided by that same base b, but raised to the positive a power. And it's really important to note that an expression is in simplest form when there are no negative exponents. So if you're asked to simplify an expression and you see a negative exponent, you just have to do this one quick trick to get rid of that negative exponent. So you take 1 and divide it by that expression using a positive exponent. So that would have been helpful for us to know at the very beginning of this lesson. When I asked you, what is 2 to the negative third power? Well, that's equal to 1 divided by 2 to the positive third power, which is equal to 1/8. Sorry about that. So here are some mistakes to avoid. And I've seen these a lot, and I have a feeling we're going to see them again, even though I'm presenting these mistakes to you. But let's see. 2 to the negative third power equals -6. So what was the mistake here? Well, the student just simply multiplied the base by the exponent, which we should all know by now is incorrect. So 2 to the negative third power is not equal to -6. Let's not do that. Here's another mistake to avoid. 2 to the negative third power equals -8. So the student applied the correct exponent and did 2 to the third power to get 8, but then said it was equal to a -8. So a negative exponent does not imply a negative result. It actually implies a fraction. And so now we know that 2 to the negative third power is equal to 1 divided by 2 to the positive third power, or 1/8. And notice it's a positive. So these two mistakes, let's not do that. Let's do one together and see what an example would look like. So the question says, simplify the expression 5a to the -4th power. Well, first of all, to simplify this expression, I kind of have to break it apart to see what really is the base that's getting raised to that -4th power. So I see 5a to the -4th power as 5 times a to the -4th power. So now I can see that 5 does not have a negative exponent. Only the a does. So a is the base that needs to be simplified. And so we can rewrite that as 5 times, and then we have to think a to the -4th power, well, that's equal to 1 divided by a to the +4th power. And now we can simply multiply 5 times 1 because we multiply the whole number by the numerator and then we divide by the denominator. So this gives us 5 divided by a to the 4th power. Do you think you're ready to try one on your own? Give it a shot. Simplify the expression 8x to the negative 6th power, y to the 3rd power. Use the strategy I used in the guided practice with you to try this one on your own. Please pause the video. And so here we have the answer. To simplify this expression, we first break each term apart with multiplication. So we have 8 times x to the negative 6th power times y to the 3rd power. The only base that has a negative exponent is the x. So that's the only factor here that needs to be simplified. And so we simplify x to the negative 6th power by taking 1 and dividing by x to the positive 6th power. And so when I bring it down, notice I have arrows there because I'm going to use the commutative property to switch the two factors at the end. So I want to put the y cubed with the 8 and then that fraction over there by itself. And I don't know if this is going to work. So here I have 8 times y cubed becomes 8y cubed, and then that gets multiplied by 1 divided by x to the 6th power. Again, when multiplying a whole or a non-fraction by a fraction, we multiply the whole number by the numerator and then divide by the denominator. And so that gives us the result of 8y cubed divided by x to the 6th power. How did you do? Okay. In this lesson, you have learned how to simplify expressions with negative exponents by exploring patterns and making connections to your prior knowledge. At this time, you can continue your worksheet. You have another problem on the bottom and then a few more on the back. And then I'd like you to jot down some ideas on the back where it has that box that says big ideas. So write down some things that you think are really important to remember and what was the purpose of this lesson. When we get back to the classroom tomorrow, we will continue exploring more patterns and working with negative exponents. All right, enjoy the rest of your day and we'll see you tomorrow.